Good afternoon, and thank you for giving me the opportunity to present here. I am Iftekhar Dipta, PhD student from University of Wyoming, and we are working with Dr. Patrick Johnson's group from the Iowa State University to extract the graphene oxide from Wyoming Powder River Basin coal. And in this study, we are trying to introduce new graphene oxide into the concrete and compare this graphene oxide with the commercial one, what we get commonly available on the market. So in the background, we all know the cement industry accounts for around 8% global carbon dioxide emission. In the last year, the cement production in the whole world is 4.5 billion tons, and from the common equation, we say that we emit 4.5 billion tons of carbon dioxide into the environment. So researchers are trying to eliminate this carbon dioxide cement consumption into the whole world. And last 2 days, I saw a lot of researchers are working on different types of supplementary cementitious material into the concrete. And researchers are trying to improve the conventional concrete. Some are trying to increase the high performance concrete, and some are working on nano-engineered concrete. Under the nano-engineered concrete, they are focusing on carbon nanotube, graphene oxide, nanosilica, and so on. My research is focusing on that graphene oxide scale. Before diving into the topic, I want to thanks to the professor from the University of Manchester who discovered that graphene oxide in 2004. And within 6 years of the discovery, they got the Nobel Prize. That means the acceptance of this material into the whole world is huge. So graphene oxide, or the graphene, is the pure structure of the two-dimensional with a single layer of carbon atom. It has incredible high physical properties, like the Young's modulus is 1 terapascal, tensile strength is 130 gigapascal. It has some thermal conductivity and some elastic properties. The pure graphene has some other additives like graphene oxide, reduced graphene oxide, and graphene nanoplatelets. Out of all of the applications of the graphene oxide nowadays in the whole world, researchers has interest to use this graphene oxide into the concrete and cement industry. Some of the research are showing that adding less than 0.1% of graphene oxide can reduce the cement consumption or the concrete consumption more than 30%. The common graphene oxide, or the graphene that using the whole world, is commonly from the graphite. And the graphite is more precious material, and people are using different types of method like the Hammers method or the modified Hammers method to extract that graphite to get graphene oxide or the reduced graphene oxide. But as I previously told, that graphite is most highly valuable materials. That is why the end product of the graphene oxide nowadays is highly valuable products and high price as well. If we see the structure on the graphene oxide on the surface, there are lots of ions present on the surface like the carboxyl, hydroxyl, epoxide, and carbonyl ions. There are some hypotheses that these ions helps to react with the cement and make some flower-like crystals onto the surface of the graphene oxide, which may help to create more dense structure into the concrete. There are lots of other benefits as well in the concrete by using graphene oxide, but researchers are focusing on some problems in the graphene oxide, like the workability decreases and the dispersibility of the graphene oxide into the concrete, as well some optimization of the graphene oxide doses. The most barrier, researchers are finding the cost of the graphene oxide nowadays. So keeping all these things in our mind, we are trying to reduce the price of the graphene oxide by adapting different raw materials to extract graphene oxide and introduce it into the concrete. This is our main research of this project. Our main graphene oxide we are collecting from Wyoming subbituminous Powder River Basin coal, which is collecting from the most west region of the USA, from the Montana and the Wyoming border, from where we get more coal mines. And you know that nowadays in the USA, mostly in the west region, the coal production is now decreasing, which implies on the job employment as well. So we want to revamp that business in a positive way to introduce that Powder River Basin coal into our concrete. So we collect that Powder River Basin coal with a price of $0.016 per kg. And as I previously told, that the graphene oxide production is under the lab production level. So still we are calculating that the price of the graphene oxide is $3 to $4 per kg, whereas in the whole world or in the USA market, we see that the graphene itself has the price of $320,000 per kg, and the graphene oxide is $14,000 per kg. So in the first phase, we try to reduce the price from $14,000 to $3 to $4 of the graphene oxide price. And we select the subbituminous coal from the 4 types of coal because of its carbon properties, like it has 35 to 45% carbon in it, and it has low heating value than the bituminous coal. We extract that graphene oxide by bypassing the Hammers method or the modified Hammers method in the whole world that is normally they are using. We are using different oxidizing agent, nitric acid, to extract the graphene oxide. And in some analysis, we found that from 1 gram of char, we can get approximately 1 gram of graphene oxide. And from that 1 gram of graphene oxide, by eliminating the other impurities, we can get 0.73 gram of reduced graphene oxide. That means the byproduct of the graphene oxide is very less than the other method. So we did some microstructure analysis of graphene oxide, different types of graphene oxide. In the commercial graphene oxide, under the 3 different scale from 20 to 5 nanometer scale, we found that the shape is more like the crumble shape, and the lateral size is 0.2 to 10 micrometer, whereas the pH value is 3.57, carbon to oxygen ratio is 0.83. Whereas our graphene oxide from the scale, the same scale 20 to 5 nanometer scale, our lateral size is 0.3 to 1 nanometer, and the pH is 3, carbon to oxygen ratio is 1.84. The same description is for our reduced graphene oxide as well. We did some XRD analysis to find the crystalline properties of our graphene oxide and the commercial graphene oxide. If you see the peak value, the peak intensity, the D spacing, and the peak position, there are lots of difference between our graphene oxide and the commercial graphene oxide. The high peak intensity and the low D spacing indicates that our graphene oxide has more crystalline phase and the stable phase than the commercial graphene oxide. We use our graphene oxide into the concrete with a percentage of 0.05% by weight of cement, and we consistent our water cement ratio of 0.6. Whenever we introduce our graphene oxide into the concrete, we saw in the workability situation, the commercial graphene oxide, the slump value of the commercial graphene oxide decreases a lot than our coal-derived graphene oxide and reduced graphene oxide. In terms of density of concrete, there is not much change between the 3 to 56 days age of curing. The most impressive result we got in the compressive strength situation, like in till 28 days, we can see that there are some increment of the compressive strength whenever we are using graphene oxide. But at 28 days, most of the graphene oxide, like from our graphene oxide and the commercial graphene oxide, shows approximately the same result. But at 56 days result, our graphene oxide shows more better than the commercial one and the control mix. So if we do the percentage analysis, our graphene oxide of 42.5 megapascal is 20% higher than the commercial graphene oxide and 27% higher than the control mix. Till that point, we fix that our graphene oxide has some improvement or has some comparable result with the commercial graphene oxide. After that, we choose our graphene oxide and we expand the range from 0.05 to 1.5% of the graphene oxide into the concrete. And interestingly, we found that whatever the percentage we are using into the concrete, there is at least some improvement in every percentages of graphene oxide. That means it has some impact into the concrete. And in most of the region, if you see in the 28 and 56 days, in most of the region of getting high percentages of graphene oxide is 0.05 to 0.1% of graphene oxide using in concrete, which align with the previous studies of the researchers. We also did calorimetric analysis to find out that whether introduction of graphene oxide change, alter, or create any other peaks or any change of the peaks. But fortunately, we found that there is not much change in the heat flow and also the cumulative heat diagram. But we saw that some increment in the peak of graphene oxide 0.05% into the concrete. Under the curing period of 28 days, we did some other tests under the range of 0 to 0.25 of graphene oxide. we found that the flexural and split tensile strength does not change that much, rather it did not decrease much than the control mix. Also scenario we found in the modulus of elasticity and Poisson ratio that it does not change or alter the products. So in the summary, we can conclude that the optimal range of our graphene oxide is in between 0.05 to 0.1% in the concrete to get high strength like the 27.6% strength than the control mix concrete. So this is an ongoing project, and we are also currently working on other mechanical properties, microstructural and durability of concrete, and we want to introduce some other additives into the concrete to see that whether this graphene oxide affects in the concrete properties or not. So far we submitted patent and journal for our research, and I want to thank you, University of Wyoming School of Energy Resource, US Department of Energy, to giving us the fund to complete this project. Thank you for your attention.